Hello everyone. In this video we are going to discuss practice exercise 1.4 from your very first chapter, that is vector algebra. So very firstly we are going to start with what is given to us. So we are given with the two vectors, that is vector A and vector B. So what is that vector A? That vector A is equals to AX plus 3AZ, and we have another vector, that is vector B, and that vector B is equals to what? 5AX plus 2AY minus 6AZ, and we have to find out what is the angle in between these two given vectors. Okay, so very firstly we are going to rewrite that vector A because we have the missing component along the y direction over there. So if you are going to rewrite that one, so we have the 0 component along the y direction. So this is complete matter of practice. If you are any enough practice, then you can skip this step, and if you don't have any confidence, then I would suggest that you should go with this traditional way of rewriting that vector given vectors if there is some missing component. Okay, fine. So we have that vector A and vector B, and we have to find out the angle in between that two. Okay, so in order to find out angle in between any of the two vectors, we have to make use of the uh, any of the product. So we do have the two products. We have the scalar product and we have the vector product. This scalar product, it is also said to be what? It is said to be the dot product, and this vector product, it is said to be what? A cross product. Now, if you have gone through the theory of this vector chapter, vector algebra, so the dot product is represented by means of what? So if we are given with the two vectors, that is vector A and vector B, so the dot product in between these two vectors is given by means of what? Magnitude of vector A multiplied by magnitude of vector B into cos of the angle in between that two. So this is what we have the dot product. And what about the cross product? So if we are given with the two vectors, that is vector A and vector B, so the cross product in between these two vectors is given by means of what? Again, magnitude of that vector A multiplied by magnitude of vector B. Then here in this case we have the sine of the angle in between that two vectors. If they lie in the same plane, then that an cap. So this an cap represents you what? It is the normal to the plane. Normal to the plane where we have that two vectors, that is vector A and vector B, containing vector A and vector B. Okay, so based on your practice, I would suggest you can go with the scalar product or you can go with the cross product. But if it is not specifically given that either you have to make use of the scalar product or vector product, then I would suggest that you should go with the scalar product because it is quite easier than this one. Okay, fine. So you just take out what is given in the numerical, and based on that you just take the decision what to use, whether you have to go with the dot product or whether you have to go with the cross product. Okay, fine. So here in this case I am going to make use of the dot product since it is quite easier than the cross product, and for your practice you can make use of this cross product. Okay, so we will start with the solving that numerical. Okay, so here in this case we are going to make use of the dot product. So what is the definition of the dot product, or what gives you that dot product? So dot product in between any of the two vectors is given by means of this, that dot product in between any of the two vectors. So here in this case we have the vector A and vector B is equals to what? Magnitude of one vector multiplied by magnitude of another vector into cos of the angle in between that two. Okay, since we have vector A and vector B, so we have written it in the form of vector A and vector B. Okay, fine. Now here in this case we are going to rewrite this equation. So what will be the next step? So cos of theta of the angle in between these two vectors will be equals to what now? This product of the given two vectors, that is vector A dot vector B, is equals to, divided by magnitude of vector A multiplied by magnitude of vector B. Okay, fine. Now what is the given vector A? So we have that given vector A to be what? Ax plus 0ay plus 3az having dot product with respect to your vector B. So what is that vector B? We have that to be the 5ax plus 2ay minus 6az divided by magnitude of vector A and magnitude of vector B. So magnitude of vector A is given by means of what? It is square root of square of all of the components of your very first vector. So what is the components of vector A? So here we can see over here. So very firstly we have the component along x to be 1. Then we have the 0 component along y direction, and then we have the 3 as component along z direction. So this is the square root of your vector A. Now next is we are going to write about the magnitude of your vector B. So what will be the magnitude of vector B? So that will be square root of square of this very first component along x, that is 5 square. Then we have this to be the 2 square, and then we have this minus of 6 square. So this gives you the magnitude of your vector B. Now go with the component by component multiplication of these two vectors, that is vector A and vector B. So multiply this component Ax over here with respect to component of x over here. So what is that component that we have? This 1 into 5. So we have that to be the 5, then plus, then component of this y with respect to this component of this y. So that will be what now? 0 into 2. So we will have that to be the 0. Then we have this component along that z direction, that is 3 over here, and this minus 6 over here. So 3 into minus 6. So we will have that to be the minus of 18. So this is all about the dot product in between the two vectors. Now what about the square root of this magnitude of vector A? So if you take the square root of that one, so that will be square root of 10. And what about this? So that will be square root of your vector B. So this will be around root of 65. You can have the calculations over there. Now if you simplify that one, so minus 18 plus 5 will be minus of 13, and then square root of 10 into square root of 65. So it will be around 25.49. Okay, fine. Now next, so again simplify that one. So if you simplify that one, now directly you can go with the taking the cos inverse of that ratio. So theta AB will be what now? That will be cos inverse of your minus 13 divided by 25.49. Okay. So what will be the theta of the angle in between that two? So if you go with the calculations, you can find the angle in between that vector A and vector B is equals to 120.60 degrees. Okay, so this is the solution for your fourth numerical from your very from your very first chapter, that is vector algebra. Okay, so we are done with the solution over here. For your practice you can go with the cross product. Okay, so we will stop over here. If you appreciate my efforts, you can hit the like button, and you can share with your friends. If you have any feedback onto my videos, you can comment it in the comment section so that I can improve it further. Okay, thank you.